So let's see. So this is the idea of unit testing. And let's see now how do we actually do unit testing. So first thing we need is a unit test framework. This is a piece of software that allows us to create tests easily and with little effort. Then we have to separate tests from production. We will have a version of our code that's used that tests the software, and we will have the production code. And as we have seen before, our code is developed as a model that is used by both the test software and the production software. Third point, use a version control system. Why? Because in unit testing, I'm always making small changes. And for instance, as soon as I have a code a test that is on the green light, so it's passing, I should commit that version. Before refactoring the code and trying to improve it, the test is running, passing, commit, and then start making improvements. Because this way, if the improvements by some reason make the test fail, I can always go back to the last working version and start from that point onwards. And do unit tests all the time. Develop code, test, develop code, test. These tests should last seconds or no more than 2-3 minutes. And you should be doing this as frequently as possible. And so these three things work together. I need a unit test framework to create the tests. I need a version control system like Git, because TDD is incremental and I should save every work increment. And then I need to use refactoring, because most of the times I will have a dirty piece of code that just passes the test. I save it, and then I start improving the code, knowing that I have a working version that I can use if needed. Okay, so these are basic principles of unit test. Now, there are many frameworks for unit test. I will talk about those that are mostly used for embedded development in C and C++. One of them is Unity. Unity is written entirely in C and is dedicated to testing programs written in C. But we will use a CPPU test. The CPPU test is also a framework for unit testing. It tests programs in C and C++. CPPU test was developed in C++, and this is so it has the advantage of being able to verify code written in C++ or C. So it doesn't matter whether you're using C or C++, or you can have projects using both of them, and you can use a CPPU test for unit testing your program. The software is available in this site. You can see it now. Okay, and you can download this is free software. You can download the software as a zip file, as a tar file, or for those that are using Debian, like Ubuntu, you have a package for CPPU tests. So if you do apt-get install CVPU test, you have CVPU test available on your PC. Otherwise, you have also the instructions for downloading the code and installing the software. By the way, there is also a macOS version 2, so you can use any of these variants. But we will do this on the lab class. Today we will just see how now in this class we will see how this thing works. And finally, another advantage is that CPPU test is targeted at the embedded systems development. So which is the area where we are. And so we will now talk about CPPU test. How does a test framework works? The test framework defines a set of macros that help us create the tests. These are the macros used by CPPU test, and you will basically only need two of them, which is the test group and the test. Test group is required because every test must be part of a test group. So what we do is we create a test group, and then we include tests on that belong to that group. And what is a test? As you have seen before, a test means assigning values to variables, so creating the conditions for the test, run the software unit that's being tested, and then verify the results. And verify the results is done also by these assertions, which are also macros that are defined in the framework. There are a lot of them. We just use a few of them. You can have, so you assign values, you run your code, and then you test one of these assertions. You check that and any Boolean condition, that some variable is equal to something, that the return value is equal to this, or larger than, or smaller than. It depends on the circumstance. You can check if some text is equal to what you are check text tests the condition and then writes some text. You can check if two values are identical. You have the expected value and then you have the actual value. For instance, in the example that I talked about before, you are writing a software procedure to write the contents of a register. You have assigned values for the CPU clock frequency, for the desired interrupt frequency. You know what is to be expected to be the result to be written on the CPU register. You run your software, and then you compare what's the expected value with the actual value. And this is done automatically. So you can have all these conditions, compare strings, and then compare long values and signed longs, etc., etc., etc. So also in the CPPU test site, you have a list of all these assertions. And so things work this way. We have why is CPPU test used? Because it's simple to put in practice. You need only two files, which is called main tester, and another which is called the test runner. The first one is the main file. It only serves to store the main of the C program, and then it will call all the tests, and we write all the tests in this test runner. And so these two files are linked. They are linked with the code to be tested. And as we have seen, each test includes setting the initial conditions, running the code, calling a function, and then verifying the results. And the CPPU test also adds two more things. I can have a setup phase, which is some actions that I need to do in the beginning of the tests. And I have the tear down, which is the undoing of the setup. And so this is the main tester.cpp. It's only these 5 lines, an include and the main with just one call, as simple as this. And I have here the example of a test runner file with the tests. How does this work? I have always to include this test harness.h. If I'm using C, I need to use this macro extern C to include C files, C header files in a C++ program. So all the includes must be wrapped with extern C if you are using C code. And then you have those two macros that I've talked about before. I create a test group. In this case, I call it dummy group. And I define what's the setup and the tear down, what's to be done before and after the test. I may leave it empty, and then I create the tests. And I give a name to each test, and I use the macros, the assertions to implement the test.